Okay students, already you have got about the electrolysis, how to do electrolysis. Now I will do electrolysis of molten sodium chloride. Molten means it should be in melt condition. If you want to pass electricity through sodium chloride, you know sodium chloride is solid. If you pass electricity through the solid substance, the sodium chloride will act as bad conductor. I mean, you cannot pass the electricity in solid state because in solid state there will be no ions. That is why either you have to take molten sodium chloride or you have to take aqueous solution of sodium chloride. I mean, molten sodium chloride will produce Na plus and Cl minus ion, or aqueous solution of sodium chloride, I mean when you dissolve in water, then also it can form Na plus and Cl minus ion. I mean, if you want to pass electricity, it should create some ions, otherwise you cannot conduct electricity. So that is why solid sodium chloride is bad conductor of electricity. Now I have taken molten sodium chloride. Molten sodium chloride will ionize as follows. Sodium chloride ionizes as NaCl, will produce two ions, Na plus and Cl minus. So your molten sodium chloride contains two ions, sodium ion and chloride ion. After passing electricity, as I have told you, positive ions will move towards the cathode, negative ion will move towards the anode. So at cathode, the sodium ion will move and sodium ion will gain one electron and it produce sodium solid, and that solid sodium will be deposited at the cathode. Similarly, at anode, Cl minus ion will move, it will release electron and it produce Cl. As you know, atomic form of chlorine is unstable, that is why two chlorine atoms combine to form chlorine molecule. I mean, you will get chlorine gas. So at cathode, sodium will deposit and at anode, chlorine will liberate. I mean, after passing electricity, some reaction taking place. At cathode, gain of electron takes place, I mean here reduction takes place, and at anode, loss of electron takes place, I mean oxidation takes place. At cathode, always reduction takes place, and at anode, always oxidation takes place. Like this way, you can separate sodium and chlorine from sodium chloride compound. So this is the electrolysis of molten sodium chloride. Now, I will take aqueous solution of sodium chloride. This is about the molten. Now I will take electrolysis of aqueous solution of sodium chloride. Now there is a difference between molten state and aqueous state. In molten state, only sodium chloride is present, but in aqueous solution with sodium chloride, water is also present. So when you dissolve sodium chloride in water, sodium chloride ionizes Na plus and Cl minus ion. Like sodium chloride, water also ionized, because aqueous solution contain water also. Water also ionizes H2O, give two ions, H plus and OH minus. So your solution contain Na plus, H plus, Cl minus, OH minus. I mean solution contain two cations, two anions. Now after passing electricity, which ion will move towards the cathode, which ion will move towards the anode? As you know, positive ion moves towards the cathode, negative ion moves towards the anode. But here two positive ion, both the ion will move or only one ion will move? Actually, there will be a competition between these two positive ions. That ion whose potential value is larger, I mean higher the potential value, greater is the tendency to move towards the electrode. The potential values are given in your book, you can see the potential value. Higher the potential value, greater is the tendency to move towards the electrode. So although there are two ions present, Na plus and H plus, but at cathode, the hydrogen ion will move, not the Na plus ion, because H plus ion have more potential than Na plus ion. That is why at cathode, H plus ion will move, it will gain one electron to form H. Since H is unstable, that's why two H combine to produce hydrogen molecule, hydrogen gas. Similarly, at anode, there are two negative ion, one is Cl minus, one is OH minus ion. Here Cl minus ion have more potential than OH minus ion. That is why Cl minus ion will move towards the anode. So Cl minus will release one electron, it produces Cl. Since chlorine is unstable, that's why two chlorine combine to form chlorine gas. So ultimately at cathode hydrogen gas will liberate and at anode chlorine gas will liberate. Actually, when there are number of ions in solution, then there will be a competition between the ions who will move towards the rod. It depends on the potential value. Higher the potential value, greater is the tendency to move towards the rod. So that is why, since H plus ion have more potential, that is why H plus ion will move towards the cathode, not the sodium ion. Similarly, since Cl minus ion have more potential, that is why Cl minus ion will move towards the anode, not the OH minus ion. So like this way you can find out the product at cathode which product will form, at anode which product will form. So at cathode hydrogen gas will produce and at anode chlorine gas will produce. Now since hydrogen ion moves towards cathode, Cl minus will move towards the anode. So the solution now contain Na plus and OH minus ion. I mean the solution now becomes sodium hydroxide solution. As you know, sodium hydroxide is base. Ultimately the solution will become a basic solution. Initially the solution was sodium chloride, that is a salt solution, pH will get 7 because it is neutral. But after doing electrolysis, pH will going on increasing. Why going on increasing? Because after doing electrolysis the solution become basic in nature, because the solution now it is the solution of sodium hydroxide solution. Since it is a base, so pH value will be more than 7. That is why after electrolysis of aqueous solution of sodium chloride, the pH value of the solution going on increasing. I mean the solution become basic in nature. So this is about the electrolysis of molten sodium chloride and aqueous solution of sodium chloride. Both are different. In molten only sodium and chloride are present, but in aqueous solution number of ions are present. That's why which ion will move, that will depend on their potential value. Higher the potential, greater is the tendency to move towards the rod, and that is why hydrogen and chlorine is deposit on the cathode and at the anode. Thank you.